I hope that few of you have tried to understand that what we are going to do for this session. What is the prime, you can say, aim of working on today's session? Anyone? What is the purpose of this session? What topic we are going to understand? Any idea?
I think you mentioned RNN somewhere.
RNN, correct, RNN. So, okay, anyone tried to, you can say, to just think about RNN or anyone tried to get any idea what RNN could be, where we can use RNN, what are the application in the real-time scenario of RNN? Anyone?
Do you use it in chatbots, like to maintain um the sequence of conversations?
Okay, chatbot, good,
I'm
good.
not sure.
No worries, no worries. We will discuss about that. Anyone else? Any other example? Any idea? Okay, let's take an example to understand about RNN, right? Let's suppose, for example, if you go to Google, just open your browser and go to Google. Now, if you try to search anything, right? Let's suppose I'm simply saying that if you are trying to search for neural, it also gives you some other, you can say some other result, right? It try to predict some words, correct? Yes, no?
Yeah, correct.
Right. Now, so how this Google is predicting it? Does it have a specific method? Does it have a specific, you can say, an algorithm, okay, on the basis of which it is trying to predict that thing? No. Simply, there is a network which we are using here that is called RNN, which stands for Recurrent Neural Network. Neural network. Okay. Now understand. How many of you understand the term neural network? If anyone attended the first session where we have discussed this neural network part. Anyone there? Or any idea what is neural network?
You said neural network is used to transmit information or messages, something like that.
Okay. Okay. Anyone else? Yes or no? Simple. Otherwise, we are going to discuss it. No issues in that.
No.
No. See. So what is neural network? Basically, neural network is a you can say is a connection of different layer which can work or which can act just like a human brain. Means it has the capacity to make decision on its own. Okay. Now, how it is going to take that things. So there are different type of layer we apply. That is input layer, then we have hidden layer, then we have output layer. Now in every hidden layer we have neurons, perceptron is there, and inside that there are multiple functions generating, like summer is there, right? One activation function we use, optimization function we use. Okay, on the basis of all of that, a neural network work, correct? But you also need to understand here that neural network only works for feed forward. Feed forward. Feed forward, or we call it as sequential data. Sequential data. Now, anyone, any idea what is sequential data? How can we define, or if from the real-time scenario, if you want to give any example of sequential data, how can you define it? Guys, anyone?
No idea.
Okay. Okay. So see what is sequential data. Understand. I'm simply giving an example of the sequential data which you can relate to your daily life. Okay. See. So when I'm saying that, let's say for example, okay, I have data from the stock market. Now, try to understand why I'm discussing the data from the stock market. Is it possible that if you miss the data, let's suppose for example, I have 5 days of data, right? That is D1, D2, D3, D4, and D5. If I have 5 days of data, I can predict day 6 correctly. Yes or no?
Correct.
Right.
Yeah.
But what if happen if I don't have the data for the day 2 and day 3? Can I predict the data for day 6 accurately?
Yes, absolutely.
Yeah, is it possible for me to predict the data or predict the rate for the day 6?
Sorry, repeat your question, please. I'm sorry.
Question is, let's suppose for example, I have data for the 5 days, right? That is from D1 to D5, correct? I can predict the data for day 6 accurately. Yes or no?
Yes.
Right. What if happen if I don't have the data for day 2 and day 3? Can I predict the price for the day 6 accurately?
No, no. That's
No.
No,
impossible. That's
no,
impossible. Yep.
not possible. Correct. Now see. So this is what sequential data. Sequential data means which follow a pattern, which follows a track, which follow a sequence. Only if it is following a sequence, only then it is possible for you to generate the accurate result. Otherwise, it is not possible. Okay. Yes or no?
Okay, clear.
Right. So first thing is that RNN we use to work for sequential data, right? Now let's discuss about the practical application where we have used, where we have seen it. One example I have given that while working on any, you can say any browser, right, or in any search engine. Search engines are the best example of recurrent neural network. Why? Because in search engine you have a specific, you can say entity which separates the entire neural network from recurrent neural network. And what we call this entity is, we call it as the hidden layer, which is simply a memory. Okay, which is simply a memory, right? Getting my point? Yes, no?
Yes.
Okay. So now let's see the architecture of this neural network first of all, right? Okay. So let's go and discuss the architecture. Right. So if you look at the architecture of RNN, it is entirely different for any conventional neural network, right? What is that here the input X goes to a hidden layer H, right? And it is a recurrent like this. So we will talk about this, what this recurrent is, right? Then there is some weight associated which generates a output O like this, right? Now if I try to expand this architecture, so it will look like what happened. Now understand what happened when I unfold it. So here there is a hidden layer at ht minus 1, which takes input xt minus 1, which holds takes an input at xt minus 1, then weight associated with it, and it generates a output that is OT minus 1. Now it goes in the next state like this. Again, we have XT. Now this state will be HT, and the next state will be HT plus 1. Okay. Right. And then here we have U. So here okay, this is your XT plus 1, which generates the output as 0T plus 1. This will generate the output as 0 at time T. And with every output, there will be a weight associated. Okay. Right now.
It's like those.
Is someone not muted? Okay. Now see. So here comes the component of RNN that we need to discuss, right? So a RNN primarily having two components. One, so here we have components in RNN, right? RNN. What is the first component is called the recurrent neurons. As we are working with neural networks, obviously neurons will be there, right? So first is the recurrent neuron. Second is called the RNN unfolding. RNN unfolding, right? RNN unfolding. Okay. Right. Clear to this, everyone? Guys, anyone, any question, any doubt right now till this?
What does this weight imply here?
Okay, so weight is the mathematical entity which describes the priority of your data. Okay.
Okay.
Okay, let's understand
Kind
this.
of algorithm, right?
No, not an algorithm, not an algorithm. Understand? So when I'm saying weight, right? Let's understand like this. Let's say you are giving some instruction to a neural network. Okay, let's say I am giving three different instructions. Let's say I1, I2, and I3, right?
Okay.
Which instruction has the maximum priority, that we are going to define through this weight.
Okay. Got it.
In a layman term, you can understand it, but when we deal in the real time scenario, the weight get attached with every input.
Okay.
Okay, which determine the preference of the input. Clear?
Okay. Got it.
Right. Okay, now see, so as I said, that there are basically two main you can say components that we need to discuss. First is called the recurrent neurons. So what is recurrent neuron? Recurrent neuron says that it holds a hidden state that maintains information about previous inputs in a sequence. As I mentioned, that using the RNN, we are going to work on sequential data, correct? Right? So definitely, if it has to work on previous data, it must need to store them. Yes, no?
Correct.
Right?
Hmm.
Right. So that storing mechanism, how it is performing, that it is performing through this recurrent neuron. Getting my point?
Yeah.
Yes, understood. Yes, understood.
Okay. Now, so when we say recurrent, right? Recurrent means that it doesn't matter how many times you are working on it. Okay, it will give you the same result. Getting my point? Like for example, if I am searching right now that what is a recurrent neural network, or as soon as I put recurrent, I will get the some prediction about next word, right? Whether it is neural network, whether it's something else. But definitely, if I search any other time, I will get the same answer. Yes or no? Correct?
Yeah.
Correct.
Right. Okay, so that is what recurrent. Recurrent means remember. Simple. Okay.
Yes.
Okay. Now another one which is called as RNN unfolding. What is RNN now? Understand. RNN unfolding, right? Unfolding, or you can say unrolling. Okay. Anything you can say. Both are same. So what this unfolding say? It is the method or process of expanding the recurrent structure over time steps, right? Now understand this very carefully. This unrolling is the most, you can say, important part of understanding any RNN, right? Because if you look at the architecture, I have represented the state, that is your input and output, on a time basis. Everyone remember? Yes, no? Guys, you remember? This is let me show you this part. Here I have represented every unit as a unit of time, right? T minus 1, then T, and then OT plus 1. Yes or no?
Yes.
Okay. Right? Now see. So this unfolding on unrolling, it is related to that time step, right? So what happened actually when you are doing the RNN unfolding? Okay, what actually happened here? So when we do the unfolding, so in every you can say step, right? That is in every unfolding, each step, that is each step of your unfolding of the sequence is termed as, not termed actually, treated as, right? Is treated as a separate layer, as a separate layer. Okay. Now, what this separate layer is, what is the purpose of this separate layer, right? Why we are looking for this separate layer? This separate layer is simply do the function of how information flows, right? Separate layer which simply do the function of how information flows across each time step, right? Now, when we are saying that how information flows, if you talk about a conventional neural network, so conventional neural network is a kind of a feed forward. Feed forward. Feed forward means in which your data travels or flows from input state. This is your input state. Then get processed on the hidden layer. This is your hidden layer. And finally, it reaches to the output layer. Okay. This is how the feed-forward neural network or the basic of conventional neural network works. Getting my point? But this neural network, right, which is recurrent, it also, you can say, process your information going back, right? If you look at the architecture, in the hidden layer, I have created a circle, a loop like this, right? Remember?
Yeah.
Right. Now see, so how this loop is creating? This is nothing. This is what we called as back propagation through time. Okay. See, so understand this.
Okay.
See. So once we have this unrolling or unfolding thing, this unrolling enables back propagation through time, which is called BPTT, back propagation through time. Getting this, everyone?
Yes, sir.
Okay. Now the question is that when the recurrent neural network already has, you can say, a specific unit to store your previous input, right? Then what is the purpose of this back propagation? Why we are using it? So see, just a second, it's storm getting rain here. Just a give second, guys. Just a minute. Okay, right. So what is the purpose of this back propagation when we already have a hidden state or hidden layer exist? Understand. So definitely, whenever you are working on in any neural network or any machine learning algorithm, deep learning algorithm, there will be some chances of errors. Yes, no?
Yeah.
Right. Now, so how that errors
Yes,
you
sir.
are going to
Yeah.
rectify? Okay. How you are going to rectify those errors? Now, if you say that we will design the neural network again, so that means you have to shut down the entire process. Let's suppose, for example, if you are searching something on Google and Google is giving you wrong answer. Now, Google is trying to, you can say, just sort out that error. So they have to shut down the entire browser, entire search engine. Does it like that? No, definitely not. Correct? They don't need to shut it down. So what I have to do, I have to, you can say, create my neural network such a way that it can rectify those errors at the same time. Getting my point? That is what back propagation through time means. So using or through this, what happened? It is a learning process where errors are propagated across time steps to adjust, adjust the weights and enhance the RNNs ability to learn. Getting my point? Yes, no, till this, everyone? Clear or not?
Yes.
Anyone, any question, doubt? Okay, now, this is the conceptual understanding of how RNN work, or what will be the architecture of RNN, right? Now we will let's discuss about the, you can say, about the core part of architecture, which is your hidden state. Because see, hidden state is the only difference in your in the RNN from any conventional network, right? From CNN or ANN, it is at the only specific thing, that is all hidden state. So obviously, if it is have a different one, so there will be a different approach to work with this, correct? So we will now understand that how a hidden state is going to be calculated, because that is the main point. If you need to work on any hidden, or sorry, with any RNN. So here, let's suppose if in RNN, I am representing hidden layer by HI. So how I'm going to calculate this HI? So there is a formula which we use, which is called H is equal to sigma U dot product with X plus W dot product of HT minus 1. That is hidden state at time stamp 1, HT minus 1. That is in the previous minus 1 time stamp, plus B. This is the formula, right? Now, what is H here? So H representing your current hidden state. Current hidden state. Then this U, capital U. This and W, this. So U and W, these are the weights matrices. And what is this B? B stands for bias. Getting this? Guys, formula, direct formula is there. Okay, there is no complex computation and all that there. Direct formula is there. On the basis of this, you can calculate your hidden state. Then the next thing that we need to calculate is called the output calculation. So this is your hidden state. Let me just write it. HI is the hidden state, and another one is, let's suppose, output calculation. Output calculation, right? Okay. Now, how to calculate the output? So there is again a formula which we use, that is Y is equals to O V into H plus C, right? Now, what is this O, V, H, and C? All that. So Y is the output here. O is the activation function. This is your activation function. Okay, now first of all, tell me, how many of you understand activation function?
I don't understand.
Okay. Anyone else? Anyone else?
And even what does this bias stand for in the above formula B?
Sure. Okay, so now we are going to discuss two things. First, we have to discuss bias and activation function. Understand what is bias. So bias is a value which you provide to, you can say, to restrict the condition of overfitting. That means you want that your network is not going into the condition of overfitting. Now, what is overfitting? Understand. Overfitting says, in simple terms, okay, overfitting says that if you are getting high accuracy in the learning period, let's suppose, for example, you are creating a neural network. Okay, obviously you require some data so that your network learn. Yes, no?
Correct.
Right.
Correct.
Let's say this is your historic data, right? And on the basis of this, your neural network is going to generate some new data, right?
Mhm.
To understand it better, you can take the latest example of that chat GPT, right? everyone start generating the Ghibli art, correct?
Yeah.
Right. While many those who are you can say have a deep understanding what is happening in the industry, they restrict, they directly mention don't give your pictures to the chat GPT. Why? Because indirectly what you're doing, you are giving data to the network to learn, right? Which what the neural network is doing, what the chat GPT is doing, it is generating a new art for you, a new picture for you, correct?
Correct.
Right. But I hope, I don't know whether you have seen it or not, because uh, I have gone through a lot of you can say cases, right, in the Ghibli art, where the Ghibli art or where the chat GPT is generating some random images as well, some random objects in the image, correct? Now understand why that was happening. Because your neural network, okay, is learning from the historic data, right? And it is generating your new data. It might be possible that your neural network is making some errors, okay, or it is not efficient in generating the correct result. So what is overfitting here? We were discussing about overfitting. So how can you understand overfitting? Overfitting means, let's suppose while learning from historic data, your neural network showing an accuracy of, let's suppose I'm saying, okay, while learning from it, it is showing an accuracy of 97%, right? Okay. But when you are generating the new data from your neural network, now your accuracy reduced to, let's suppose I'm saying 90%. Okay. So this is what overfitting is. While in learning phase, higher accuracy, but in testing phase, it is getting low accuracy.
Okay.
Okay.
Okay. Yeah. Thanks.
Okay. Now, coming to the bias. Okay, so we have discussed bias, right? Now, what is activation function? Activation function is simply a mathematical entity or a mathematical formula which triggers a neuron, not neural network, which triggers a neuron to work, right? Understand more? Fine. Okay. Let's suppose, for example, okay. Let's suppose for an example, okay. What is gag reflex? Anyone? What is gag reflex?
Not
Any
heard
idea?
of it.
No worries. Okay. Okay, you might face sudden jerk in doing some movement, right? Ever happen?
Yeah.
Like, for example, you are sleeping and there is a sudden jerk in your body.
Yes. Yes.
Right? Right. Whether it's an voluntary action or involuntary action?
Involuntary.
Involuntary. But your body still process it, correct? Means how that action is generating. Obviously, without brain, nothing is possible, correct?
Mm-hmm.
Right. So definitely there will be some trigger in your brain, a specific part of your brain, which is generating that function. Yes or no?
Yes.
Right.
Yes.
Now just understand like this, try to relate. The function which is triggering the part of your function to generate that reflex,
Mm-hmm.
that is activation function.
Okay.
Okay. So in the
Mm-hmm.
same way, when you are working with neural network, in the neural network as well, we have multiple types of activation functions. So according to the need, according to the output, or according to the input we have, or data we
Mm-hmm.
have, we will choose the type of activation function. We apply that on the hidden layer and move on to the next part, or we generate the output.
Okay.
Anyone else? Any other question, doubt?
Yes, quick one. So where does the neural network, where does that fit into that equation you just explained?
No. See. Neural network, we are talking about all this hidden layer and everything. That is part of neural network.
Okay.
If you need to understand how the neural network look like, or how the architecture of it, so
Mm-hmm.
you can see like this. So this will be your input layer. Let's suppose this will be your input. Then it goes to the hidden layer. This is your hidden layer. Okay.
Right.
Where multiple neuron will be there and your information is going to be processed.
Mm-hmm.
Right. And finally, it will generate the output like this. Okay. This is a simple diagram. You can understand. This is how the neural network look like.
Okay.
Okay. So this HI that I have wrote here, right? All of that is we are providing inside this. This is your hidden layer. Getting?
Got it.
Right. Anyone else? Any other question or doubt? Yes, no, guys. Anyone? Any other question or doubt you have?
No further questions. I think we can continue.
Okay, fine. Now, so we have discussed about this, right? Okay, let's try to generate an application, a simple Python code where we can create some neural network. Okay, is it fine? Yes, no? Ready, everyone?
Yep.
Okay. So just give me a second. Let me open my Jupyter. Okay, anyone else wants to execute side by side? Okay, so open a new file and share the screen.
Oh, you share.
Yeah, it is. Now I'll share.
All right.
Everyone getting now?
Yes. Jupiter. Yes.
Network break. Okay, so let's begin. So the first thing that here we are going to do is the library that we require. Okay, you can use TensorFlow as well, and there is one more library which is you can say more familiar, or which is better to work with RNN, is called Torch, right? So first of all, let's import the library. So I'm going to import web enter now. So first of all, I'm going to import the torch. Torch. Give it control enter. Done. So it is imported, right? Now we are going to define the neural network, right? So that is why what I need to mention here, that from the torch import torch dot nn as nn, right? And one more library I require, which is import torch dot tin optimizer as optim. Execute them as oh sorry. Oh, done. Anyone executing side by side, guys? Yes, no? Or anyone wants to execute? Fine. So let's suppose, for example, I am defining a sample data here, right? So here we have sample data. So what I want here, first of all, I need to define a sequence, right? That is what sequence I want to generate, I want to get the data or get the output, right? So let's suppose I am defining one sequence here, let's suppose hello. And then I'm saying that here we are defining one variable that is called characters, which is a list type. And how it is generating? So it is generating from the variable that I have defined here, which is sequence, right? Means this character list is going to be generated from the sequence data. And why I have defined it as list, as a set, because I don't want the redundancy here. Getting my point? The set basically we use to restrict the duplicacy. Okay. Now, first of all, I need to ch character. I'm going to convert every character to the index, right? I need to calculate the index of every character. So that is why I'm putting here. If you are familiar with the list comprehension, right, then I hope it's easy for you to understand. Ch in enumerate and chars cas. Okay. Then next part, what I'm going to do, I will convert this index to character, that is char, is equal to I such that ch for ch in character to index dot items. Okay, execute this, done. So we have created a sample data here and converted the sample data to the character, and then converting back that character to the indexes. Okay, so the first step we have done here. Now coming to the next step, which is preparing input and target. Prepare input and target. So what we will write, we will simply write input. I'm defining one variable here, which is input to sequence, right? And here, sorry, character to index, and inside this I'm going to mention the ch, that is the character for ch and seq sequence. Now here I want to access the sequence, or you can say every letter, okay, from the sequence. So I need to slice it. So I am going to use the slice operator here till the last index value. Okay, this is what sequencing, slicing is. Next, I am defining one target, that is target underscore sequence is equals to index, and here I am again providing that ch for chn sequence right, done. Okay, right? So what it will do, it is going to define your target and the input here, right? Means how the target and the your input is generating. So that we have defined here. Execute this, done. Now I need to define some weights. So here I'm using tensor, input underscore tensor. Okay. So I'm defining your using a torch dot tensor. Sorry, I'm not defining the weight. I'm creating tensor, right? Torch dot sense tensor. Then okay, it will take some input from the sequence that I have created, right? And there is a method called Q. That is not showing. Okay, SQU double EZE 1 and target underscore tensor, right? Target tensor is equals to torch dot tensor target underscore SEQ. Done. We have defined the tensor for the input and target as well. Getting? Right. Now after this, from this phase, from this step, we are defining the RNN model, right? Correct? Everyone done till this? Yes or no? Guys, are you guys just executing this or not? Or just looking right now?
Just watching for now. We'll have to
Okay,
put this
no worries.
to practice. Yep.
No worries. So now we are going to define the model.
Quick,
Okay.
quick.
That is,
Do we have to we have to download a Jupyter lab in on our laptops, correct? And do some
see,
practice, correct?
if it is you have the Jupyter lab, right? You can work on Jupyter lab. Otherwise, you can work on Google Colab as well.
Okay.
No worries in that, right?
Okay.
Yeah. But see, the thing is, make sure that you have the libraries available. If you don't have the library, you first need to install them, because like this library like Torch, Keras, TensorFlow, PyTorch, these are generally not available. So you first need to import them. You first you need to install them, then you import it. Okay. Okay. So
Got it.
let's share uh, class. I'm creating a class. Let's say BS basic RNN, right? And in this, I'm going to provide NN and module. Now, need to define a function init. Then in init, we are going to put the self hidden state, sorry, input size first. Input size, and output underscore size. So these are the three parameters I am providing in my function. Now, defining one class here, that is super, which is generating from basic RNN, self, and init. Self dot RNN is equals to NN dot RNN, and I need to define the input size here and the hidden size here. Okay, then self dot hidden size and your output size. Okay, then def one more function, that is forward function, self, and a unit, an input x, out, size. Defining the size of the output, right? That is one more bracket, right? 1, 2, 3, right? Okay, so what is this? This is your flatten layer. Flatten layer output, right? Now we will define some parameter for the model. Model parameters, that is your input underscore size is equals to the length of the character that is generated, chars. Then your hidden size is equals to 8, and your output size, that is entire length of the chars, right? Now one hot encoding we have to perform. What is, okay, any idea what is one hot encoding? One hot encoding. Anyone? What is one hot encoding? One hot, right?
No idea.
Okay, see, what is one hot encoding? Anytime if in your data you have categorical data. Categorical data means a data which exists in the form of text, right? And have categories. So how you are going to make it possible for your algorithm to understand that? For that purpose, we are using this method which is called one hot encoder. It simply converts all of your you can say data into specific categories, that is numerical, right? Let's say for example, if I'm saying I have data of different regions, right? Let's say I have data from 4 different regions, north, east, south, west. So what it is going to do, it will convert all of the north where it is written north as 1, rest 0. Then in the next column it will convert the next one as 1 and the rest are the 0. So one hot encoder only, you can say, convert your data in binary, that is in 0 and 1. That's it, nothing else. But the problem is with the one hot encoder is that you can't define your own encoders. You can't define your own values there. Also, it will increase the dimensionality of your data. Means it makes it more complex, right? IN underscore sequence please.
You're missing an S with the unsqueeze.
Sorry. Initialize model. Model is equals to basic RNN, which will having your input size, then return size, and output size. Then we are dot loss entropy loss. Right. I need one more, which is optimizer. MIZT or optimizer is equals to optim dot atom. Sorry, atom model dot what is not giving me parameters, and learning rate I'm defining as 0.01, right? Learning rate should be as minimum as possible so that your algorithm or your neural network or whatever model you are creating, it must learn effectively. Now this is your training phase. Training. So for EPOCH in range 100, I'm defining, right? Sorry, optimizer dot I need zero gradient. GRAD zero gradient, right? Then output. Okay. Output is equals to model, which will take input one hot, then loss is equals to CRIT criterion. Here I will take the output and the target tensor. Done. Then calculate the loss x backward, because we are working with backward, right? We are working with RNN, so definitely it is going to be I set dot p I set e cdr dot step done. Then generate the prediction output dot arg max. The dimension I'm defining as 1. Then thread underscore characters is equals to dot join method I'm using, right? And I'm joining every index to char ith item for in thread. Now I'm putting one condition: if POCH epochs, if epochs plus 1 modulus 10 is equals to 0. That means I'm running the epoch for every 10 cycles, right? Then print f ch epoch POCH plus 1 loss dot items, sorry, item, right? And predicted predict characters. Okay, execute this. If everything's fine, closing parenthesis where broadcast join. Okay, I finished here. Okay, it is now executing it. Okay, now wait. Cross entropy loss. Input where? Line 33. 33 loss targets. So input on defining range or to other dot zero thread. So right hitting mouse to backward. To other all the stuff. Well, what is happening? Cross entropy loss argument input position one must be so not non type. Did I missed anything? Cross entropy I will define here. Criterion is equals to cross entropy loss. That is fine. Then cross entropy loss. Optimizer, that is also correct. I have used the nine, right? And then cross entropy, correct. Criterion. And loss is also criterion. Output and the target tensor, right? Backward loss optimizer steps are same. Prediction augment max dimension one. Yeah, right. That is also right. Now what is happening? No worries, I'll check it, guys. Although there is a very slight mistake I'm making here, right? I just need to look into it, and then I'll forward it to the. Okay, is this fine, everyone? Clear?
Yes, yes. Please, quick question.
Uh-huh.
What's the best way to get an understanding of all the code you just wrote? I mean, I like what you're doing, but
Mhm.
to get acclimated and to get an understanding of what you're doing and how to translate everything you're doing, what should we do?
Okay, see, so honestly, you have to learn Python first of all,
Okay.
right? Then learn about the libraries, because I am using some functions which only available in the library. If you understand the library, only then you can know what kind of function I'm using or what is the purpose of using those functions. Like let's suppose, for example, cross entropy I'm using here, right? What is the purpose of cross entropy? What is this Adam? Correct. I have discussed what one hot encoder, right? Okay. In the same way, when I'm defining this tensor, so what do you mean by tensor? what is the purpose of tensor. These things you can only understand once you go through the library or once you have the entire understanding of the concepts of the library as well as programming. Only then it will be possible.
Thank you.
Anyone else? Any other question, doubt? Yes, no? Okay. So that is all for my side for today, guys. I hope you guys have learned, although it's very quick, but I hope you guys have learned little bit or you get an understanding of the ANN. Yes, no?
When is the next when is the next class?
Next class will be on next Saturday.
Next Saturday. Okay. Same time. Okay.
Yeah, same time. Okay.